Wish you a very good morning to all. So we'll continue our topic. So we'll quickly revise the Fleming's left hand rule and Fleming's right hand rule. So Fleming's left hand rule, the stretch the thumb, forefinger and middle finger of your left hand such that you will get this type of look. You can see here when you manage your left hand in this way. If forefinger points in the direction of magnetic field, the middle finger in the direction of the current, then thumb will point in the direction of motion or force. So here we can say that the forefinger shows the magnetic field, middle finger shows the direction of the current, and thumb point towards the motion or force. Now my dear students, heart and brain in the human body have significant magnetic field line. So that is why for the some measurement and some find out the magnitude of the particular organ which we consider as internal organs, we are usually go for the MRI, that is magnetic resonance imaging. Image of the internal organs of the body can be obtained using magnetic field of the organ. And generally galvanometer, it's an instrument that can detect the presence of current in a circuit. It also detect the current, the direction of the current. Now important topic we are going to discuss in your textbook, that is page number 114, that is electric motor. Now electric motor is a rotating device that converts electrical energy to the mechanical energy and mechanical energy to the electrical energy. So two-way it's working. So here you can see the diagram, the same diagram which is given in the textbook. So principle of the electric motor is totally based on the Fleming's left hand rule and electromagnetic induction. So here an electric motor consists of a rectangular coil, that is ABCD of the insulated copper wire. The copper is placed between the two poles of the magnetic field such that the arm AB and CD are perpendicular to the direction of the magnetic field. So they are arranging in such a way that they are always be parallel, and the ends of the coil are connected to the two halves P and Q of the split ring, and the inner side of these halves are insulated and attached to an axle. So here some important things are there, that is split rings and or we can say as a commutator. The split rings S1 and S2 are the two halves of the copper ring which are attached to the axle and rotate it. The two ends of the coil are attached to the split ring, as you can see in this figure, or you can see in the textbook figure also. And the external conducting angles edges of the P and Q touch to conducting stationary brushes X and Y respectively. So brushes connect the external battery to the commutator. Current in the coil ABCD enters from the source battery through the conducting brush X and flowing back to the battery through brush Y. The force acting on arm AB pushes it downwards, while the force acting on arm CD pushes upward. So downward and upward direction force is moving, applying. Thus the coil and the axle O mounted free to turn about an axis, and that is rotation is anti-clockwise. That is half rotation. Q makes contact with the brush X and P with brush Y. Therefore, the current in the coil gets reversed and the flows along the path DCBA, means totally opposite, that is clockwise. The split ring acts as a commutator which reverses the direction of the current and also reverses the direction of the force acting on the two arms AB and CD. The main function of the split ring acts as a commutator which reverses the direction of the current and also reverses the direction of the force. Thus the arm AB of the coil that was earlier pushed down is now pushed up, and arm CD previously pushed up is now pushed down. Therefore the coil and the axle rotate half a turn more in the same direction, and the reversing of the current is repeated at each half rotation, giving the rise to a continuous rotation of the coil and to the axle. Commutator, which is a device that reverses the direction of the flow of the current through a circuit, is called a commutator. Remember, my dear students, what is commutator, which we are using the split rings? Armature, the soft iron core on which the coil is wound, including the coils, is called armature. It enhances the power of the motor. So armature plays an important role in the electric motor. The commercial use of motors, generally an electromagnet is placed in the permanent magnet. A large number of turns of conducting wire is in the current carrying coil, a soft iron core on which the coil is wound. Now next is electromagnetic induction. So electromagnetic induction, when a current is placed in a changing magnetic field, some current is induced. Such current is called induced current, and phenomena is called electromagnetic induction. So here one activity there, you can see electromagnet that already we have seen in our previous video presentation. When the magnet move into the coil, the monetary deflection in galvanometer indicate the presence of current. Magnet kept stationary inside the coil, no deflection. Magnet is withdrawn, monetary deflection in G but in the opposite direction. So whenever we are moved towards the north pole, there is a deflection. If magnet is stationary, there is no deflection, and magnet in the south means withdraw. It is a opposite direction. Now next experiment also, coil 1 and coil 2, switch on, the monetary deflection in galvanometer you will observe, steady current, no deflection. Switch off, the monetary deflection in G but it will be opposite. So it indicates that north pole and the south pole. When the north pole there, monetary deflection, and if it is steady, there is no north pole, south pole, that is no deflection. Switch off, switch means south pole, monetary deflection in the opposite direction. Then Fleming's right hand rule. Fleming's right hand rule totally due to the induced current. Remember that the Fleming's left hand rule for the current only, for the direction of the current, and Fleming's right hand rule that is showing the induced current. The hold the thumb, the forefinger and the middle finger of the right hand at the right angle to in such way. So if the forefinger in the direction of the magnetic field and the thumb points the direction of the motion of the conductor, and then the direction of the induced current is indicated by the middle finger. So induced current is explained by the Fleming's right hand rule, and only the current is explained by the Fleming's left hand rule. Remember the difference between Fleming's left hand rule and Fleming's right hand rule. Working principle of an electric generator. Now used to find the direction of the induced current. Now electric generator, as we have discussed, electric generator mechanical energy is used to rotate a conductor in a magnetic field to produce electricity. An electric generator consists of rotatory rectangular coil ABCD placed between the two poles of the permanent magnet. Here, and the two ends of this coil are connected to the two rings R1 and R2, the inner side of these rings are made insulated. The inner side of these rings are made insulated, and the two conducting stationary brushes B1 and B2 are kept. The same method what we have discussed in the electric motor. The generator also, the mechanism is same. Two rings R1 and R2 are internally attached to an axle, and the axle may be mechanically rotated from outside to rotate the coil inside the magnetic field. The outer ends of the two brushes are connected to the galvanometer to show that the flow of the current is in the given external circuit. So galvanometer also connected. When the axle attached to the two rings is rotated such that the arm AB moves up and the arm CD moves down in the magnetic field produced by the permanent magnet. After the half of a rotation, arm CD start moving up and AB moving down. As a result, the direction of the induced current in the both the arms change, giving the rise to the net induced current in the direction of DCBA means totally opposite. The current in the external circuit. So here two circuits are there. One is the internal circuit, one is a external circuit. Now flows from B1 to B2. First it was B2 to B1. Now it is B1 to B2. Thus, after every half rotation, the polarity of the current in the respective arm changes. To get a direct current, a split ring type commutator must be used. With this arrangement, one brush is at all times in the contact with the arm moving up in the field, while the other is in the contact with the arm moving down. The direct current always flow in one direction, whereas the alternating current reverse its direction periodically. So AC and DC type of currents are there. So AC for the alternating current and DC for the direct current. AC, the current which reverse its direction periodically, and in India AC reverse its direction in every 1/100 second, and time period 1/100 plus 1/100 is equal to 1/50 seconds, and frequency 1/time period is equal to 1/50 means 50 hertz. So time period 1/50 seconds and frequency and 50 hertz. Advantage of AC generator. AC can be transmitted over long distance without much loss of energy. Disadvantage of AC cannot be stored. Now direct current, this current which does not reverse its direction. So DC can be stored. Loss of energy during transmission over a long distance is high. The source of DC cell, that is cell, battery, storage cells, that is a DC. Now domestic circuit, last and final topic of this chapter, that is a domestic electric circuit. There are three kinds of wires: live wire, neutral wire and earthing wire. Live wire which is positive, neutral wire which is negative, and earthing wire which is generally green in color. So live wire red insulated cover, neutral wire black insulated cover, and earthing wire green insulation cover. The potential difference between the live and the neutral wire in India is 220 volt. So the current which is coming to our house, that is 220 volt, and we are using live wire and neutral wire. So pole start the main supply, then convert to the fuse, electrical meter, a distribution box to separate circuits. So this diagram you have to draw whenever the electric circuit type of question will be asked. So domestic circuit, in that you have to explain the live wire, the phase wire, neutral wire and earthing wire. Now here the problem is, you can see here in the diagram also you can see the live wire and neutral wire coming from the main line, then main fuse, then electrical board, main switch, then distribution box to the other room, and vice versa, it is going to the different rooms. So earth wire protect us from the electric shock in case of leakage of current, especially in metallic body appliances. It provides a low resistance path for current in case of leakage of current. Short circuit, it's very common when live wire comes in contact with the neutral wire accidentally. The resistance of circuit becomes low, which can result in overloading. Overloading, when the current drawn is more than current carrying capacity of a conductor, it results in overloading. So when the large amount of current flows in the circuit beyond the permissible value, this is known as the overloading. And overloading occurs when the many electrical appliances hike in a voltage supply. So accidental hike in a voltage supply, there will be fault, and the use of more than one appliance in a single socket. Now safety devices, that is electric fuse, earth wire, and MCB. MCB we generally using nowadays, that is a miniature circuit breaker. So here now question arises, why it is earthing done? So in our house or factories, we often touch the metallic body of electrical appliances barehanded and barefooted. If by fault the live wire comes in contact with the metallic body of the appliances and we touch the body, we will receive a reverse shock. To avoid this, appliances are earthen. On earthing the appliance, the large current passed through the copper wire instead of human body. Hence, the earthing protects us from any accidental electric shock. So, that is why we are using earthing and electric fuse. Electric fuse is a safety device which is used to save electrical appliances from burning. It is used in the series with the live wire. Electric fuse consists of a wire of low melting point which melts when large amount of current flow into the circuit. On melting, that disconnects the circuit and stops further flow of current in the device and saves it from burning. Generally, the fuse wire of 5 ampere and 15 ampere rating are used in domestic circuits. So this is the end of this chapter. Most of the topics we have discussed. From your physics today also, different diagrams related to topics are there that are also important for your exam. So that all things we have to remember, all things we have to draw. So this is the end of this chapter, and next video presentation we will go for the NCERT solution. So thank you and have a nice day.